Hey folks, it's Andrew from Gemba Red, and today we're going to do a quick test on what's the difference between different lens angles, as well as how it relates to the distance you need to be away from a panel. Now I've got two Sadie-Lite BS360 panels here. However, I modified the panel on the left to use our 60-degree beam angle lenses that are lightly frosted that we use in our reboot and overclocked panels. And the original Sadie panel has the 30-degree beam angle lenses that seems to be pretty standard for panels that you get directly from Alibaba. That's their standard one. But you might be able to ask them for a modification if you place an order, or you might be looking for panels on the market that have different beam angles. But this test is to finally do an apples to apples comparison of if you've got two identical panels, same power, same size, same number of LEDs, same wavelengths, and we only swap the lenses. Now we can see what's the real influence of just swapping the lenses and how your intensity changes with distance. So anyway, let's get started. We've got our prototype PBM meter here, so that way we can kind of see a nice big display in milliwatts per centimeter squared. We don't have to do any conversions. And so now we have both of them on with both red and near infrared modes. And again, we can check they're both consuming nearly identical power outputs, 132, 131. So again, these are, practically identical panels, except for I swapped out the lenses on the left one. Okay, so 6 inches away for the 60-degree lens. 67 milliwatts per centimeter squared. Now 12 inches away, 60 degrees. Drops to 49 milliwatts per centimeter squared. So already this is where you start the ideal PBM range. Okay, 18 inches away, 60 degree, and it drops to 31. Okay, 24 inches, a whole 2 feet away. 22 milliwatts per centimeter squared. Still a good intensity, might be good for skincare. Okay, a whole 3 feet away. What's the intensity? 12 milliwatts per centimeter squared. So on that lower end of non-contact therapy might be still an ideal intensity to get that lower dose. Also, I realized I had the other one on. I turned it off, but it was not having any impact on our measurements because the beam angle was so narrow it wasn't reaching over to this far. Okay, now the 30-degree lens angle panel. We're starting at 6 inches away, and it's 61 milliwatts per centimeter squared. Okay, we're 12 inches away, 1 foot from the 30-degree panel. And still really high, 58 milliwatts per centimeter squared. So you'll still be in a warming kind of range, even at 12 inches away. So we're 18 inches away of 1.5 feet, and we're still at 52 milliwatts per centimeter squared, even at 18 inches, so it's still a little bit higher than we would like for the ideal PBM range. Okay, 2 whole feet away, and we're at 46, so we're in that PBM range, but still on the upper end of the range. Okay, a whole 3 feet away from the 30-degree lens panel, and let's see what it says. 33 milliwatts per centimeter squared. Okay, we'll do one more measurement at 4 feet away for the 30-degree one because its intensity is so high. At 4 feet away, it's at 24 milliwatts per centimeter squared. Again, that's where you might want to be at the starting point to make sure you don't get an overdose reaction, or if you're just focusing on skincare. So anyway, that's the demonstration. We can see there are differences in how the beam intensity kind of drops off a little bit faster with the 60 degree, and it stays stronger for the 30 degree. Again, there's some pros and cons to why you might want that. With 60 degree, it tends to be a little bit more gentle on the eyes and gentle on the face and the body. And you have more control within a reasonable amount of distance from 1 to 3 feet away. You can choose your distance appropriately and get the right intensity. Where the 30-degree one, especially with a high-powered panel with a lot of LEDs, then you have to start being much further away, maybe at least 18 or 24 inches away, just to start off in the right intensity range, and being much further away if you want lower doses like for skincare. So these are important considerations. It's not about what's best or worse. It's about choosing what's right for you, how much space you have in the room to kind of play around with different distances. If you want to use them closer and have less of a footprint and take up less space, or use them further away so you can kind of maybe do an exercise in front of it or multitask in front of it. But this really highlights, the combination of very high powered plus very narrow beam angles can create kind of more constraints and more problems, where if you had high powered and wide angle LEDs, that might be a better trade-off. So thanks for tuning in. Hopefully that helped.